All right. Hey, happy Halloween and happy Thursday. Thank you for checking out today's math webinar. My name is Dennis, and I will be facilitating this session with you. A little about what we're going to do today. We are going to just go through the helpful formulas worksheet. So if you do not have that, please look in the handout section now and go ahead and download that. We are going to be using those formulas as they are written in the helpful formulas worksheet. But we are going to be doing some different examples. One of the things that I always encourage folks to do, particularly if you find math scary, as my friend Paul here does. This is Paul Bones. In honor of Halloween, he chose to join us. So if you find math intimidating or scary, a couple of things that are going to help with that, particularly as it pertains to this type of fitness assessment math that we're talking about, is really it's practice. Be comfortable doing the formulas. You have all the information you need on the helpful formula sheet to really do those formulas step by step. Sometimes it's helpful to memorize the formula. In fact, every time it's going to be helpful to memorize the formula, but particularly to memorize and understand why we do it. So if you are in the camp of folks who behave like this when you see math, scared, I'm going to challenge you to reframe that belief that you have in yourself as it pertains to math. That might sound like, while in the past I found math intimidating, I am working at making it accessible to me. And it kind of alleviates the pressure you'll put on yourself where it comes to math, particularly if you are the type of person who wants to maximize the number of points you can achieve on your exam. These are some pretty easy gimmies if you spend the time practicing. So if you've downloaded the helpful formulas worksheet, we are going to use that. When this webinar ends, I'm also going to encourage you to go and practice those formulas. Use your own body metrics in some of these formulas. If you don't know your body fat percentage, make it up based on what would be realistic for someone of your age, height, and gender. What would you like to get your body fat percentage down to? Do the math according to that. Break out some nutrition labels that you might find in your kitchen cabinets. Do the math according to those labels. The more you can do it, the more comfortable you become doing it, the easier it will become. And eventually, of course, the goal is that when you get to the exam, you know how to do those formulas because you cannot take your helpful formula worksheet in with you. You will have calculators provided to you at the exam site. They are calculators that are built into the testing software, so you cannot bring your own calculator. You will be using one that is part of the testing software. You'll have an opportunity to do a demonstration or a demo of the test software before you begin your test. I highly encourage you to do that. It takes about 3 minutes. Your 3 hours for the exam does not start until you complete that demo. If you choose to skip that demo, your 3 hours starts immediately and you cannot go back. So take advantage of that demo. Also, you will be provided scratch paper or a 5x7 dry erase board with a dry erase marker. So if that is what happens and you're the type of person who's planning on walking in and writing down all those formulas right away, just know that you're going to be given a dry erase board that's not very big with a pretty thick tipped marker. Just be prepared for how you're going to deal with that. So into the math webinar we go. The very first thing I always want to cover, and I apologize to those of you who know this, but for those of you who find math confusing, it's important to understand that you need to please excuse my dear Aunt Sally. I'll say that again. Please excuse my dear Aunt Sally. In math, there is what's called an order of operations. And that is because if we saw something like this, 7 plus 6 times 5 squared, and I apologize, my handwriting's horrible, plus 3 equals what? Where would we start? If we just did this straight across, we wouldn't have consistency in how the math is performed. So there's a very specific way that we do math problems. We always start with please or parentheses. So that means we would only look at what is inside the parentheses, and that is 6 times 5 squared plus 3. Well, now we have an exponent, so there's something a little scary going on there. We can't multiply 6 times 5 squared plus 3, not just yet, because now we have to follow the e, exponents. We would have to work within the parentheses first, but now we need to focus on this exponent. So we would get 7 plus 6 times 5 squared, which is basically 5 times 5, 6 times 25 plus 3, and parentheses. Now we can continue with our, please excuse my dear Aunt Sally. Sorry, I just got a note that I should bring this easel closer to the camera. I'm going to attempt to do that without destroying my easel. So let's see if that helps. All right, so now we have 7 plus 6 times 25 plus 3. We continue with our PEMDAS. Please excuse my dear Aunt Sally. So we still can't 7 plus anything, so it's still 7 plus 6 times 25, because now we're doing multiplication, right? According to, please excuse my dear Aunt Sally, we don't do any addition yet, so we have to multiply. So we're going to look at 6 times 25. And that gives us 150. So now we have 150, which is 6 times 25 plus 3. Still have to complete the parentheses. The parentheses are still the very first thing we're working on. So 150 plus 3 is 153. 7 plus 153, your answer is 160. We came to that working through the please excuse my dear Aunt Sally. Little caveat to that, something you'll always want to be aware of, is that while you do always want to work within the parentheses first, as we did here, you're going to look for any exponent, so any square, square root, power of, as we did here, 5 squared. Solve that first, continue working through your parentheses, and then you would work multiplication or division. Those can happen in any order. If you were to divide before multiply within the parentheses, that's okay. In reality, this is parentheses, exponents, multiply or divide, then add or subtract. So when it comes to multiply, divide, add, subtract, those can happen in any order, as long as we are working within our parentheses, exponents first, okay? So let's move on. If we're going to define a couple of terms that we will be seeing. So first of all, when it comes to fitness math, we're looking at things like body composition. We're looking at lean mass, fat-free mass, or body fat percentage. So it's important to understand what all of those mean. First of all, body composition. That is going to be your proportion of lean tissue to body fat tissue. So lean tissue would be muscles, connective tissue, your bones, your blood, your nervous tissue, your skin, and your organs. So it's important that you understand that. Lean body mass, again, muscles, connective tissues, tendons, ligaments, your bones, your blood, nervous tissue, skin, and organs. And it's also important to know your lean mass, this is metabolically active tissue. That means that this allows your body to perform work, and as a result of it, it burns calories. So you'll hear people who are like, I'm working out, gaining a lot of muscle mass, but my weight hasn't changed. That's okay. The muscle mass is metabolically active, so that is requiring calories. So your body composition has changed, even if your weight has not. Then we're going to talk about fat-free mass. That's the part of body composition that represents everything but fat, which is what we just talked about, right? Lean body mass. So do not get those confused. They mean the same thing. Fat-free mass is also lean body mass. So again, that's muscles, connective tissue, bones, blood, nervous tissue, skin, and organs. Then we get to the term body fat percentage, which is exactly what it would sound like, right? It's the total mass of the fat in your body divided by the total body mass. So now we're looking at fat divided by muscles, connective tissue, bones, blood, nervous tissue, skin, and organs, collectively our lean body mass. Plus fat is in there. So fat divided by lean body mass plus fat. By the way, if you do have any questions along the way, you have a question feature on GoToWebinar. Please feel free to put those in. I'm going to make an effort to answer those before the session ends. And if I see them along the way, I'll also answer them during the webinar. So if you don't know how to find that, you're going to see your go-to navigation pane. You'll see something that says questions with a little white arrow next to it. Just click on that white arrow. It'll drop down. It'll say enter text here. And also, I'm going to unmute you all. So please know that I've unmuted you. So I'm going to ask that you mute yourself on your own line. And here's why I'm doing that. I'm going to be asking you occasionally what the next step is as we're moving through something. So right now, please mute your own phone line so I'm not hearing you, but we are going to be asking you what are the steps we should be taking. So you should be following along with your helpful formula sheet. So on the helpful formula sheet, the very first one is calculating your desired body weight, or DBW. All right, so we're going to use an example here. So to figure out desired body weight, we are going to, the desired body weight equals our lean body weight divided by, parenthesis, 1 minus desired body fat percentage. Oh my God, what does that mean? Let's talk about it. So let's say you have a 190-pound person, and this person has 22% body fat. How much would this individual weigh if he decreases his body fat? If he decreases his body fat to 14%, what would his weight be? So if you want to bring yourself off mute, who wants to shout out, what do you think might be the very first step we would need to take? You have it on your helpful formula sheet. I'll give you a couple seconds if you want to come off mute and shout it out. No takers. All right, so let's start here. We're going to take 100%, the entire body, and we're going to subtract from that just the body fat percentage. And that will give us lean body percentage. All right. So what we would take is 100 minus 22. Let's try a different color and see if that makes it easier for you to see. 100 minus 22. That's going to give us 78% or 0.78. The other way you might see this written is 1 minus 0.22. Same thing, we're just making this into a whole number versus a decimal. If you're with me so far, please let me know. So we now know that this person has 78% of their body is lean body, is 78% of their body is lean, 22% of their body is fat. So now we're going to try to say, well, what is their lean body weight? How much of that 190 pounds is lean body weight? So we would take 190. You can still see me? Great. 190 times 78%, and that's going to give us 148.2 pounds of lean body weight. That means of the total 190 pounds, 148.2 of that is lean body weight. So now we want to say, well, what will this individual weigh if they get down to 14%? So we're going to come back to this number in just a second. We're going to come again. Let's see, you're going to still see this. Great. We're now going to take 100 and we're going to subtract 14%, and that's going to give us 86%. So if this 190 pound individual had 14% body fat, 86% of it would be lean body fat. So now let's take their lean body weight, remember 148.2, and divide that by 86% or 0.86. Getting close down here. 148.2 divided by 86%. That's going to give us 166 pounds. That means if someone got down, if someone at 190 pounds, 22% body fat, and they lost, what is that, 8% of their body fat, their weight would become 166 pounds. Now, here's a caveat to that. This formula is basically used for the purpose of the exam as an easy way to demonstrate to someone what changes will happen to their body if they decrease their body fat percentage. The calculation assumes that throughout the entire fitness program or weight loss program, that the lean body weight does not change. So in real life, it should be noted that there might be, with any weight loss or weight gain program, that there is typically a change in the amount of both lean body mass and fat mass. That's a little harder to calculate because it's going to vary for each individual. But as far as just using this formula, it does provide guidelines. It helps people understand the changes that occur due to changes in body composition. So the reality may be that this individual maybe only gets to 170 pounds and still gets a 14% body fat, but we can't calculate for that because each individual will be different. So, sorry, y'all couldn't see anything but the red marker? Okay, I will stick to only the red marker. And someone asked, why is 148.2 divided by 86%? What did I do wrong? You're right. Yeah? 148, thank you. Someone caught my error. Thank you. 148.2 divided by 0.86 is actually 172. Awesome, someone's catching me. So thank you for that. That is a great catch, Pinar. Thank you. That is actually correct. So 148.2 divided by 86% is actually 172 pounds. I don't know where I got that. So nonetheless, it stays the same. So someone at 14% body fat got to 172. You know, that may or may not be realistic. They might be 180 because they increased their muscle mass. But again, we cannot account for that. So those things are harder to account for. So, sorry, I will only write with the red marker because, yeah. Oh, and that was Christy. Thank you, Christy, for catching that. I will only write with the red marker moving forward so that you all can see this, since I did receive notice that nothing else is visible. So I appreciate that. Let's move on to the next one. So the next formula is your waist to hip ratio. Oh, hold on really quick. Someone says, how will that be worded on the exam? On the exam, that question might be worded one of two ways. You might see your new client, Dennis, has come to you and his current body weight, or his current weight is 190 pounds, and he has a body fat percentage of 22%. How much would Dennis weigh if he got his body fat percentage down to 14%? And then you'd be given some options. So that's how that would be worded. And as long as you follow that formula, you're going to find the right answer. Now, another way that could be worded is your new client, Dennis, has come to you and he weighs 190 pounds with 22% body fat. What would his body fat percentage be if he got his weight down to 172 pounds? You still do the same formula. So as long as you know the basic framework for the formula, you're still going to be able to find those answers because you're just really going to plug in different values. So in that situation, you would use that exact same formula, but instead you might say 100% minus X% equal 172 pounds, right? And we would still take that original 148.2 that we found with Dennis or with me, I'm your client, by the way, 190, my 78% of my body being 148.2. We would still do those same steps. We would then say 100 minus X% equal 172. We would take negative X equal 172 minus 100, negative X equal 72. Cancel the negative because we don't have negative percentages. Then we would say, all right, we knew 148.2 divided by 72. Let's see if that works out. This might not work out and I might be lying to you all. I didn't plan to actually do it that way. Ignore that. I apologize. You probably are not going to see that on the exam because I just did the math. It actually doesn't work out. So let me think on that and I'll come back to that, but I don't actually think you would see it that way. I think you would only see it the very first way. So I do apologize. Didn't think that one through. So, all right, someone says they want an example question. All right, so find the waist to hip ratio. An example question, how you might see it on the exam. What would be the waist to hip, or actually this, what category would your client fall into if they had a 33-inch waist and 35-inch hips? Now, this will also require you to memorize a chart in your personal trainer manuals and in your health coach manuals that give you the guidelines for what's considered appropriate. So you will need to refer to that. I don't have that in front of me, so you might want to look at that. But what's most important here is you're going to want to understand that its waist to hip ratio is exactly what it says. It's waist divided by hip. So 33 divided by 35. And that is a 0.94. Now, if you refer to your chart in your book, you'll see that a 0.94, I believe, falls in like just barely healthy, because there's also two types of fat body shapes you want to be aware of. And those are the android or apple shaped. So that means you have excess fat in the abdominal area, or gynoid, which is pear shaped, meaning you have excess fat in the hips area. And it's important to know that people who would have that apple shape, the excess fat in the abdominals, they have a higher waist to hip ratio and they generally have a greater health risk. So Yes, Jenna is telling me that on page 210 in the personal trainer manual, you can find the waist to hip ratio norms. So I would encourage you to make sure for your exam purposes, you know the upper, middle, and lower thresholds of those norms, because you might find something that asks you to answer a question about it. So you might see it like this. Your new client, Dennis, has a 33-inch waist and a 35-inch hip. Where does he fall in the table as far as norms? It might say something more sophisticated than that, but again, you'll have to know how to do this, waist divided by hip, and then know what those thresholds are in that table. There is also a way to do body mass index, or rather waist to hip ratio. Sorry, I lost my train of thought. Know that waist to hip ratio chart. You have to have an understanding of, again, upper, middle, and lower thresholds so that you can say, okay, Dennis has a 0.94 waist to hip ratio. What category does that put him in? So that's how you're going to see that worded on the exam. Remember, it'll ask for category. What category does that put someone in the waist to hip ratio? And again, page 210 shows you that norm. The next one, and probably everybody's least favorite, BMI. Why is it least favorite? Well, particularly because for fitness-related folks, most of us have a BMI that puts us in an obese category because body mass index does not account for muscle mass. However, still very helpful for general population. There are two ways to calculate BMI. One is the metric, and just so you know, you'll be given these values in your exam, both in standard and metric. So in metric, we're using kilograms and your height in meters. So your formula is kilogram, weight in kilograms, divided by height squared. But that height is in meters. So weight, gosh, I have horrible handwriting, I'm sorry. Meter squared, height. Thankfully, you all have this sheet in front of you because I have horrible handwriting. So if you are off mute and we were doing this in metric, what would be the first thing we need to do to convert pounds into kilograms? Anyone have any idea? Pounds into kilograms. Divide by 2.2. Absolutely. Thank you, Pinar. So if we again have a 190-pound person, 190 pounds, and we want to know what their weight is in kilograms, we divide by 2.2 because 1 kilogram equals 2.2 pounds. 190 divided by 2.2. This is someone who weighs 86.36 kilogram. And we're going to divide that by the height in meters squared. So if I have someone who weighs or is 6 foot tall, what's the first step? We want to get feet into what? Anyone want to take a chance off mute shouting it out? Inches, you say? Yes, of course, we want to get 6 feet into inches. So how many inches are in a foot? 12. 6 times 12, 72-inch person. Still have to go a little bit further. We know that 1 inch equals 2.54 centimeters. So we now have to take 72 times 2.54. 182.88 centimeters. So 72 times 2.54 equal 182.8 centimeters. But we're looking for meters squared. So how do we get centimeters into meters? Anyone? That's right. We divide by 100. So now we get 1.8288 meters, which we're going to round up to 1.83 because if you'll remember your rudimentary math, 5 and above you round up, 4 below you round down, 8 rounds that to 1.83, but we need it squared, which is again 1.83 times 1.83. 3.34. 3.34. So now we're going to divide 86.36. 3.34. What do we get? 86.36 divided by 0.34. 25.8. Which, according to BMI, I would be obese. So Jenna again is pointing out that page 208 for the BMI reference chart in the personal trainer manual. So someone has a great question. Erica's asking, instead of converting, can't we just use the formula in weight in pounds, height in inches squared? You absolutely can, and that is a great segue because that is BMI standard. A lot of times people find this one easier, but this brings us back to our please excuse my dear Aunt Sally, because here's how this formula is written. We start with a bracket. Inside the bracket is parentheses. Then we have the weight in pounds times 703. 703 is a conversion factor. So if you're wondering where that came from, it came from a lab somewhere. So as long as you remember, if you're doing it standard in pounds and inches, you just have to remember that you're going to multiply pounds by 703. And then you're going to divide by height in inches. Close that parentheses, close your bracket, and then divide again by height. So what does that look like? Here we have meters squared, kind of the same principle. This is basically inches squared. So if we take that same, actually let's use a different example. We'll use a different sized person. Yes, Preston, metric and standard, you get the same answer, but you're doing something different. Here you have to use this conversion factor of 703. So let's just say, well, we'll try it. 190 pounds times 703, parentheses, bracket, bracket, oh, not bracket yet, divide by 72 inches, close bracket, divide by 72 inches. Let's find out what happens. It should work out the same way. Might be 1 or 2 points different. So we're going to work within our parentheses first. 190 times 703, 133,570, 133,570 divided by 72, which is 1,855.14 divided by 72 again. Answer, 25.76, rounded up to 25.8. So you get the exact same result. It's just a matter of which one do you find easier? Which one are you gonna remember? Myself, I was trained and taught in kilograms and being converted to pounds, centimeter or inches being converted to centimeters to meters. That's the one I remember. This, for whatever reason, as simple as it is, confounds me because of that 703, because my mind goes to, where does that 703 come from? Does it matter? No, it's just a constant. It's just a constant number that's used. You can use whichever one is best for you. So you might see this question on your exam written like this. Your new client, Dennis, comes to you and he weighs 190 pounds and he's 6 foot tall. what is his BMI and what category would he be labeled in according to his BMI. So you would do your math, and again, that exam is going to provide you both kilograms and centimeters. It won't provide you meters, it will provide you centimeters. So it'll say your new client dentist is 190 pounds, parentheses, 86.3 kilograms and 6 foot tall, parentheses, 182.8 centimeters, then the rest of the question. So you would answer, because you would have to know what, again, are those upper, medium, and lower thresholds for BMI. You would answer, my new client dentist has a 25.8 BMI and would be considered overweight. What are the limitations to that? Is your new client dentist, also works out a lot, so maybe he's not overweight. But again, general population, BMI is a healthy tool just to give people a starting point and an understanding of where their body is. And Jenny is saying, so we won't have to know both metric and standard. We can choose which one makes the most sense for us. That is absolutely correct. You are able to choose whichever one of those is easier for you to remember, but I encourage you to practice whichever one you choose and stick to it, memorize it, and get good at it. So Christy is saying 1,855.4 divided by 72 equal 25.76. It was actually divided by 72 squared, Christy, so I think you may be, I'm assuming you are doing, yeah, so if we look at 1,855.14 divided by 72, 25.76. Yes, that is correct. But remember, we round up to 25.8. That second place, that hundredths place, the 6 rounds your 7 to 8. So you got the right answer. Just be aware that on your exam you may see it rounded. Now this next one is predicted 1 rep max, 1 RM. Quick caveat. Only personal trainers will see this on your exam. Health coaches and GFI do not have to know 1 rep max. Only personal trainers. PT only. Second caveat. This formula is based off of following the 1 rep max protocol, where you warm your client up, you have them do a lightweight 10 reps, add, wait 3 minutes, add 5 to 10 pounds, lightweight 10 reps. The goal is you want to get your client to a point where they can do 10, but not 11 clean reps of a certain weight. And then you're going to refer back to, I believe it's table 8.23 on page 243 in your PT manual to know that that conversion is basically saying if you can complete 10 reps, not 11, 10 clean reps, that is about 75% of your 1 rep max. So predicted 1 rep max, pretty simple this one, as long as you are following that it's the pounds lifted. So we're going to use an example, 220 pounds for, what page number again, Christy? Page 243. So on page 243, when you're using table 823, you're going to see if someone can complete 1 rep all the way to 10 reps. So if someone can complete 220 pounds in a squat, but only for 6 reps, we know on that table that 6 correlates to about 0.85 or 85% of 1 RM. 1 RM. So we would take 220 divided by 0.85, and that's going to give us 258.8. So that's basically saying if someone can complete 6 reps, not 7, not 5, 6 reps of 220 pounds on a squat, they would be able to complete 1 rep max of 258.8. Now I happen to know that if you complete 10 reps, 10 is considered about 75%. So I'm going to do something, and I want to just see if we said 220 pounds at 10 reps, what happens if we divide by 0.75? So 220 times 0.75 would be a 1 rep max of 293. Makes sense, right? If someone can squat 220 pounds only 6 times, their 1 rep max would be 258.8. If they can squat 220 pounds 10 times, 75% of their 1 rep max, their 1 rep max would be 293. Makes sense, they'd be a lot stronger. So yes, personal trainers, you need to at the very least know table 8.23 and understand that you might see a question that says, your new client, Jill, comes to you and she can squat 220 pounds for 10 reps. What would be her estimated 1 rep max? You have to know that 10 correlates to 0.75 on table 8.23. If that question says your new client, Jill, can squat 220 pounds for 6 reps, what is her 1 rep max? You need to know that that table on 243, table 8.23, that 6 reps corresponds to 0.85% or 85% of 1 rep max. So again, personal trainers only. All right, yes, we're going to try to get through all of these, Rhea. I'm going to stay here until we do. You're welcome to as well. This will be recorded and sent to you. The next one on your helpful formula sheet is the Karvonen formula, or the heart rate reserve. This one has a couple of steps to it that you have to know. So you have to know someone's resting heart rate, and you have to know the percentage of intensity they want to work at. So for instance, a 45-year-old man, age 45, with a resting heart rate 51 beats per minute. What would be his target heart rate at, again, target heart rate at 60% intensity and 75% intensity? Here's what we have to do. We use that Karvonen formula that is on your worksheet. You have to know it. 220 minus age equal 175. That's the predicted max heart rate. But we also, to find heart rate reserve, right? HRR, heart rate reserve, we need to take the predicted max heart rate and subtract resting heart rate. So 175 minus 51, that's going to give us 124 heart rate reserve. So now we want to know, what does this client have to do at 60%? Here's where we take the full formula. And again, that whole full formula is heart rate reserve times percent of intensity. We have some parentheses here, plus resting heart rate equals target heart rate. So now we have all these numbers. We have our heart rate reserve, 124. We want to know at 60%, so times 60%. We'll add in resting heart rate, 51 beats per minute, and that will give us target heart rate. So again, our order of operations, we do those parentheses first. This one's pretty simple. We simply take 124 times 0.60, or if you want to use the percent feature on your calculator, you type 60, then hit percent. That'll give it to you. So this becomes 74.4 plus 51 equals 125.4 at 60% intensity. So if this individual is working at 60% intensity, their max heart rate is going to be 125.4. Or sorry, their target heart rate. Target heart rate would be 125.4. So that basically means if I'm on the treadmill and I'm running and I want to be working at 60% intensity and I'm doing heart rate training, I'm going to keep my heart rate at 125.4. But if I want to work at 75% of my max heart rate, we do all this same formula here, but now we're going to plug in 75 right here. So it's 124 times 70% plus 51 equals 93 plus 51 equals 144. Target heart rate at 75%. You might see this question listed as, just like I explained it, you have a new client, 45 years old, has a resting heart rate of 51 beats per minute. What would be his target heart rate if he wanted to work at 60% of his max heart rate? What would his target heart rate be if he wanted to work at 800, or if he wanted to work at 75% of his max heart rate? So this is percentage of max heart rate. Is 175 the max heart rate? Yes, Preston, it is. It's the max heart rate that doesn't take into consideration resting heart rate. So figuratively, yes, but when we take into consideration resting heart rate, we're looking at 124 for heart rate reserve. So just a plain 220 minus 45 has just too much variables, because, you know, if I'm a 45-year-old guy who's running marathons and you're a 45-year-old guy who's sitting on the couch, just knowing 175 is not actually accurate, because we're not going to have the same heart rate response to exercise. So it's important to know resting heart rate. A lower resting heart rate is an indicator of a stronger heart. So if you have a client who has a higher resting heart rate, they're going to have a lower heart rate reserve. So this heart rate reserve number for this example, Preston, is technically what we're considering our working number. But yes, in theory, 175 is that max heart rate, but again, does not take into consideration the differences in fitness. It just simply looks at age. So use the Carbonin formula that is on that helpful formulas worksheet that asks you to take into consideration resting heart rate and heart rate reserve, because you'll have a much better response, and it takes into consideration someone's fitness level, because again, where does 220 come from? That is just part of a, that is just another constant that is given. For the purpose of the exam, that's the one you'll want to use. You might have also seen the Tanaka formula, which is like 206.9 minus something in parentheses. That also doesn't take into consideration resting heart rate. So the 220 is just a standard way of saying that the max amount a heart could be is 220 beats per minute. Boom, 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 boom. But then we subtract someone's age to get this kind of guesstimated max heart rate, but that again doesn't take into consideration what their actual fitness level is. So we have to find heart rate reserve, and we have to know their resting heart rate. Resting heart rate will be given to you, age will be given to you, you will have to find heart rate reserve, and then the percent intensities will also be given to you. Then you'll have to do your math. All right, moving down, this is the next one. Here's your example. That is in chapter 8, Preston. I don't have the exact page in front of me, sorry. Total calories and percentage of calories. So here's your example. If you have a nutrition label that says 2 slices of pizza give you 63 grams of carb. And if you don't know this, carbs are generally abbreviated as CHO for CHO. You're going to see 27 grams of protein and 24 grams of fat. So again, there's some constants that you need to know. You need to know that there are 4 calories per gram of carbohydrate. And you might see that, again, kcal, which is a kilocalorie, which is what we know as a calorie. So you'll see it as kcal with lowercase k. There is also 4 kilocalories in 1 gram per gram of protein, and the heavy one, 9 kcal in 1 gram of fat. So on your exam, you might see, GFI may see this as well. On your exam, you might say, how many total calories are in this? 23 grams of carbohydrate, 27 grams of protein, 24 grams of fat. So this one would be a relatively straightforward. How many calories are going to be in this 2 slices of pizza? We would basically take 63 times 4 to come up with, oh, we're going to run out of room here, 252. 27 grams of protein times 4 calories per gram equal 108 calories. 24 grams of fat times 9 kcal per gram of fat equal 216 calories. So if the question asks you how many calories are in this food item, you simply add those up, right? You would take 252 plus 108 plus 216 for a total of 576 calories. That was in 2 slices of pizza. What if they tell you that on the nutrition label, 2 slices of pizza is the serving size and there's 8 total slices? So if that is what we get for 2 slices of pizza, and you might see it this way, you might see a question that says 1 serving size of pizza, in parentheses 2 slices, is 63 grams of carbohydrate, 27 grams of protein, 24 grams of fat. How many calories are in the entire pizza? And it'll say serving size 2 slice, total number of slices 8. So that one, again, pretty simple. 576 times 4. You're going to have a total calorie in that whole pizza, 2,304 calories. But what if it says to you, what percentage of your 2 slices of pizza? So it'll say something like this. You have 2 slices of pizza that equals 576 calories. How would it be worded? 576 calories in 2 slices of pizza. What percentage of that pizza is coming from carbohydrates if there's 252 calories in the carbohydrate serving? So now we're doing the math backwards. We know that we have 252 calories. We're going to divide that by 4. It'll be the same number, but I always like to make sure. 252 divided by 4 is 63 grams. So that's basically saying that in 252 calories, how much is that grams of carbohydrate? So 252 calories divided by 4 grams, that's 63 grams of carbohydrate. What if we wanted to know the percentage of 576 calories? What percentage of that is carbohydrate? We would then 576 divide by 252. Yeah. And that oh, what did I do wrong? Sorry, don't listen to me. Try that again. If we want to find the percentage of calories from carbohydrate, this is how the question might be worded. You might have been asked to do this math. And the question might be worded like this. Of you have a one serving size of pizza is a total of 576 calories. 252 of those calories come from carbohydrate. What percentage of calories is coming from carbohydrates? So that's when we would take our 252 number of carbohydrates divided by 576 total calories, and that's going to give us 43.75, or we round, actually, what it actually gives us is 0.4375. For the math fans in the house, we just know that we move that decimal place 2 points. But what we really do is we then multiply by 100, because we want to get a whole number in percentage form. That's what gives us 43.75, or 44% of those 576 calories come from carbohydrate. You would do the same math for protein. 576 is the total, 108 from protein, so we would take 108, divide that by 576, 0.1875, or 18.75% of our total calories is protein. Same for fat, we still take 576. We know that 216 of those calories are from fat. So 216 divided by 576 gives us 0.375, or multiply that by 100, 37.5 of 576 calories comes from fat. All right, any questions? I apologize, it's a lot of information to throw at you all. You know, again, if you just practice your helpful formulas worksheet, practice those numbers, use your own numbers, ask friends and family members to share their numbers with you. It all works out if you just follow the math and you remember your please, excuse my dear Aunt Sally. Make sure you're always within parentheses first. Any exponents, work those first. If they're inside the parentheses, then multiply, divide, add, or subtract. We did go over, so I appreciate you all sticking with me. If you do have any questions, please feel free to put those in now. I don't want to keep you all any longer because I feel like I didn't plan well and we're here a lot longer than I expected, but that's because math is fun and it just takes a lot of practice. You have to do it a lot. Where can I find the previous webinars? Gail, if it was a webinar that was conducted on a Thursday, those are recorded. As long as you registered for them, you had the recording sent to you. If you were talking about a webinar on a Monday or Wednesday, that was like a health coach study session, personal trainer study session, group fitness instructor study session, those are not sent out. Those are not recorded. Those require you to be there to ask your questions. Those are not recorded and sent out. So you have to, if you want to go to a particular study session for either personal trainer, group fitness, or health coach, you do have to show up, register, and be there for it. Pinar says, there are so many tables regarding the norms of calculations. Which are the ones that we should be memorizing? If it is a helpful formula, if there is a formula on the helpful formula worksheet, you want to know the tables and values associated to that formula. That means the upper, middle, and lower thresholds. So again, BMI, waist to hip ratio, those type of things, you want to know those thresholds. If there is a bunch of tables in your manual and you're not seeing the formula on the helpful formulas worksheet, you probably don't need to memorize that table. Oh, Rhea, yeah, you know what? You're right. There is one more formula. I am going to go ahead and complete it. I apologize. I just realized that, Rhea. Yes, I will go ahead and do that one more. You're welcome to check out if you all need to get going. If not, I'm going to go ahead and do one more formula. I did forget. This one is calculating the daily caloric deficit that's needed to achieve your desired weight loss in a set time. I'm going to stand for it because I'm a little tired and sore from sitting. Preston, does the exam want us to memorize all of the percentage of RM table? Rep max table 8.24, yes, you'll need to know all of that. So daily caloric deficit. So first, it's important to know 1 pound equals 3,500 kcal. Always important to start there. That is just a constant. You have to know it. So let's say, as the exam might say, you have an individual who wants to lose 40 pounds in 50 weeks. What daily caloric deficit is needed? So lose 40 pounds in 50 weeks. What is daily caloric deficit? Daily caloric deficit is needed. So let's start. What's the first thing we want to know? We want to know how much total calories does this person have to burn in 50 weeks in order to lose. So we're going to start by taking 40 pounds by 300 or 3,500. And that's going to give us 140,000 total calories. So in order to lose 40 pounds in 50 weeks, someone is basically going to burn 140,000 total calories. We want to know how much do they need to burn per day. So let's break that down. Let's first, what do we have? We have a weekly value. Let's calculate the weekly deficit. And remember, for the most part, it's considered 4 weeks per month. But we're going to just take that full number. Let's figure out this weekly deficit. So first we're going to take 140,000 total calories over 50 weeks. And that's going to give us 2,800 calories, kcal, per week need to be lost. But the question asks for a daily deficit. Well, now we know there's 7 days in a week, so now we can divide this by 7. 2,800 divided by 7 equals 400 calories per day for 50 weeks to achieve a weight loss of 40 pounds. Pretty straightforward, that one. But here's where it gets tricky. What if your question says you have an individual you have this same individual, they want to lose 40 pounds in 50 weeks, and they are burning 350 calories a day by exercising 3 times per week. So let me say that again. They're burning 350 calories 3 times per week just in exercise. So we have to take that into consideration. So let's say then if we know that their exercise calories being burned, 350 times 3 equals 1,050 additional calories per week being burned. All right? So what is the daily average now? Before, without exercise, is 400. So 350 times 3 is 1,050 additional calories per week. Let's figure this out on a daily. So she's only doing that 3 times a week. So let's divide that number by 7, and that's going to give us 150. So on average, she's burning 150 extra calories per day. Because we have a daily average here, we're going to turn this into day. So we're now going to take, oh, you're getting to where you can't see me, 400 minus 150 equal 250. So she would have to have a caloric deficit of 250 calories per day in addition to burning 150 calories per day, or on average of 1,050 per week, in order to lose 40 pounds in 50 weeks. Any questions on that? And again, I apologize, I've stayed a little later. Any questions about the caloric deficit calculation? Or any other questions whatsoever at all? And I'm going to apologize, folks. This was a little scattered. This was, the easel was maybe not the best method. I wish I could find a way to do this on the screen. But unfortunately, writing with a mouse has proven to be really hideous. So I do hope that this was a little bit helpful. When I end this session, this webinar, you are going to get an opportunity to fill out a survey. So any feedback you have is appreciated. This is our first attempt, my first attempt at doing the math formula this way. I always want to make sure we can find a way to do this for you and make this stuff easy and digestible. Preston is saying, how do you subtract the daily calorie intakes by the ones you burn? Great question. So yeah, what you have to do, so in my example, I said that this individual is burning 350 calories 3 times per week, in addition to her caloric deficit. You know, what would that be? So what we did here is, so we know 350 times 3, 1,050. That's saying that this person's burning 1,050 extra calories per week. But we already found a daily deficit. So we have to take something that's happening 3 times per week and average it out over the entire week. So we divide that 1,050 by 7, and that's what says, on average, if she's burning 1,050 calories a week, working out 3 times per week, she's on average burning 150 per day. So we're going to subtract her 400 calorie deficit minus her exercise deficit, and that's what gives us that 250. Did that answer your question, Preston? Sorry, if not, you're off mute. You can also speak it if you'd like. Cool. All right, well, if there are no further questions, I apologize again. This ran a lot longer than I'd planned for. Clearly, I'm a poor planner. Thank you for your time. Again, this will be recorded and emailed to you within about 48 hours. And yeah, fill out the survey if you have a chance, like 2 to 3 minutes. Good, bad, indifferent, whatever you share helps us grow and make better webinars for you all. Thank you for your time. Happy Halloween and have a great weekend.